Hi gents, we're going to complete the final section of our Unit 1 booklet, which is resultant of non-concurrent forces, and I'll read this out to you. In some instances, it is necessary to determine the resultant force that would replace a given system of non-concurrent forces. By replacing a number of forces with one resultant force, the overall load on a beam can be easily determined. So what we want to find is, we want to find a distance on that beam, we want to find the actual total resultant, and we want to find what angle is that resultant force being placed on that beam. Okay, so let's have a little look. There's a couple of examples we have, but we're going to jump straight into exercise 2. Okay, that's going to be our first one. We're going to jump into exercise 2. There's about 7 in this book. So that's our first one there. We want to find the resultant for this beam. So I've done a little replica again. Okay, we got a vertical force of 600 newtons, an angled force of 600 newtons at 60 degrees, and then 3 distances. So the first thing we should always do for this, first thing we want to put on our page is our Cartesian plane. So we've got our plus, plus, take, take. That's our first thing we should be doing for this. Okay, because we know we need to find resultant. The next thing we want to put on our page is this. Now we used this in the past. It was cat ra in the past, but now we want to add in our distance. We want to use cat rad. So step 1 is our Cartesian. Step 2 should be our cat rad. Writing that on our page so we can follow these little steps through. Okay. So as you can see, our first part for this is components. We want to start to do the components for this. So what do I do first? And because these forces are the same in the fact that they both say 600 newtons, I label these first up. So I name that force 1 and that one force 2, just so I don't get mixed up. Okay, now we'll start the components. So we'll start over here. Force 1, 600 newtons. Okay, over here, force 2, 600 newtons. There are 2 forces. Now we want to find the force horizontal and the force vertical, okay, for this. Now, formulas for that. Force horizontal is equal to force cos angle. Force vertical is force sine angle. Okay, so let's have a little go. So 600 newtons, our first force, horizontal. Okay, it doesn't have one. So that's 0 newtons. Vertical, right? Does it have a vertical? Yes, because it's going vertical. Okay, so you don't need to use that. You're just writing in 600 newtons. Now, is that positive or negative though? It's a negative, isn't it? So we put our little arrow. All right. Now I said this in the past. Either arrow is fine, but if you want to put a negative in front of that 600, you can too. It's up to you. Okay. Force horizontal for this one. Now this is an angled force, so we need to use these, don't we? So force horizontal, force is 600, cos, angle 60, good. That gives us a force of 300 newtons, it's a negative, so our arrow goes this way. Okay, force vertical, what do we have? 600 again. This time we're using this one, so sine 60. Type that in, 519.62. Again, it's a negative, it's going down, so you put in your arrow. Okay, it's good. If we have a look at our little chart here then, components, give that one a tick. Okay, we've done that. Our next step is to add. So we're going to add it over here. So put in a little add symbol, okay, for force horizontal. Now we're just adding them up. So 0 plus 300 newtons, which we know is a negative, okay. So we go 300 is equal to, good, negative still. So 300 newtons, arrow to to say yes, that's a negative 300. Okay, total for force vertical. Force vertical. Okay, good. So what is it? 600. Good. Plus 519.62 is equal to 1119.62 newtons. Again, it's a negative, so we need to go down. Okay. Okay, good. So that there is our add. So we got our little chart here. Okay, that's our add. Give it a little tick. Beautiful. Our next part is our triangle. So we need to do a triangle now. So this is where those arrows become really important now. Okay, because they're giving us the direction of this triangle. And we'll do this over here. So our first one goes down. Okay. Now remember, you're writing in a figure. It doesn't have to be you're not writing in a negative. The negative is giving you the arrow direction. 300. So it goes this way. Put the arrow on 300. Then we want to do resultant now. So remember, the arrows must clash. So wherever you started from, arrow goes down to where it clashes. Okay, and you write in your resultant, because that's what we're looking for, and we got in our angle in that corner too. Beautiful. So now we've done our triangle. You can give that one a little tick. Good. Now we want resultant. That's what we need to find now, resultant. Okay, so we'll switch back to black. So for resultant, let's put this in. So we got our resultant. Okay, is equal to, we know we always do the square root, which is just force vertical squared plus force horizontal squared. Okay, now that resultant is 1159.12 newtons. Okay, so that's what we need. That's what we found out there. So now we found the resultant. Okay, now we want to go to our angle. Now we always remember we're always using tan for our angle. So we just do it here. So our angle is equal to tan. 1. Okay, 1119. So force vertical over force horizontal, which gives us an angle. Remember, we round this to a whole number in degrees. Good, 75 degrees. Okay, so we've just ticked 2 off there. Resultant we've done. Beautiful, give it a tick. Okay, angle, we found that too now, so give that a tick. Now this is our new part. This is our cat rad. This is the rad bit, the distance. Now this is where we put our moments in. So before, when we were doing reactions of supports, up here we had our RL, our RR. So you can write them in. RR, RL. Remember we said we always want to try and start from the left if we can. Okay, only if we can. So we want to do moments now. Okay. So we got moments around RL is equal to, now there's only 2 forces in this, isn't there? 1, 2. Okay, you don't recognise this one. We're not finding reactions that support, so we don't recognise it. We're just finding these 2. So force times distance plus force times distance. Okay, because there's only 2 of them. And now this is where we've got to use our clockwise and anti-clockwise now. We're starting at RL. Now we're starting at RL. So that 600, it's pushing down. It's a clockwise motion. So we can write that in. It's a positive 600. By the distance, so from RL, 1.5. Good job. 1.5. Okay. Next force. Now the next force we're finding. Now we just want to use the vertical force for this one. Okay, that vertical force. So it's this one in here, the force vertical. Okay, that's the one we want to use, because remember we said before about horizontal distances. Okay, we want to use vertical force. So we've actually already worked out that. So it would be 519.62. Now the distance from there is 1.5 plus 3, okay, to get to that force, so it'd be 4.5. Good job. Okay, now we've done that, we can work this out. So 600 plus 1.5 is 900, plus 519.62 multiplied by 4.5 is 2338.29. And that's telling us that our moment resultant, okay, our moment resultant is 3238.29. Now we have that moment resultant, we can go ahead and find our distance now. So that formula is moment resultant is equal to force vertical, so the total force vertical, multiplied by the distance, okay? So we know that our moment resultant is 3238.29 is equal to, okay, total force vertical, good, 1119.62 multiplied by D, okay, we don't know what D is, so we need to get D isolated, so get it on its own, okay, so D is by itself. You then have to divide that, so it'd be 3238.29 divided by 1119.62, and that should give you a distance now. And that distance is 2.89 meters. Okay, so that's your distance, and you can give that a little tick now, because you've just done the whole cat rad. Now, gents, this is essentially saying that right now we have a resultant of this much, okay, at an angle of 75 degrees, and our distance is 2.89 meters. Now remember, that there was a negative, so that's telling us where this arrow would be. You don't have to do this on your chart, this is just so you understand. But basically 2.89 meters along this beam, so it'd be somewhere about there, okay. You would essentially, it's a negative, so you would essentially have an arrow that looks something like this, okay, and it would be 1159.12 newtons, that's your resultant, okay, and at an angle in here of 75 degrees, and then the meters from there to there would be 2.89 meters, because that's what you've just found out. You're saying that is the resultant angle and how far along that beam would be. Okay, gents, have a go at the exercise moving forward, so 3, 4, all the way through to 6 or 7, okay, and have a little crack.